California's devastating wildfires, new technology is emerging that promises to transform the way blazes are monitored, fought, and ultimately prevented.
I was a line firefighter for decades, and I finished as the state fire marshal of California. So I was aware of some information gaps in the firefighting space.
There's no better vantage point to view methane emissions than from space.
We've never had this quality data for any greenhouse gas. Full stop.
Well, thank you all for coming, and it is a huge pleasure for me to be able to be on the stage with three great friends and coworkers, people with whom I've had a chance to work with for several years, and they are really the best the best in their class in the world. I'll just make a couple of brief comments of introduction, then we'll kind of dive into it. Purpose of the panel today is really to help you understand that not only is there huge advantages and opportunities on the investment side in space, but there's also huge impact that's going to happen to make the world a better place. We're going to be able to gather information. We're going to be able to fight battles that we've never been able to address because of what space is doing and the data we're going to be able to gather. Three key pieces of that today we'll talk about. One is how the technology is evolving to allow that to be more cost effective, to be able to get provide greater access to space technology at a price and a capability that's really never been possible before. And Jonny Dyer will be leading that discussion. Jonny, CEO of Muon, which is one of our portfolio companies. I've had the pleasure to work with Jonny for, what's it been? Almost 15 years.
Don't talk about how long it's
been. Don't talk about it. But he was part of our management team at Skybox to help build some very innovative and revolutionary satellites. Been involved in a number of projects together, and he's a brilliant engineer. Not only that, Jonny was a pitcher at Stanford, and I remember asking him, how come you didn't go play baseball? He says, well, I figured I could make more money as an engineer as I could as a pitcher in the Major League Baseball, so that gives you some idea of his talents. And Kate, what a joy to have Kate with us today. As you said, she's been a fire marshal, but she's really worked in fire in the state level in California, but also in the White House, is very, very knowledgeable, not only in how to fight fires, but how to manage fires, the policy side of it, and brings tremendous insight. She's currently a senior advisor to the Moore Foundation on fire resilience, and that's a very timely topic in the state of California. And then Steve Hamburg may be one of the more impactful people I've ever met. Steve is a scientist. He's the chief scientist of the Environmental Defense Fund, former professor at Brown, is involved with virtually every major climate change activity on the planet, advises and leads many of the UN initiatives for global climate change, and is currently executive director of a project called MethaneSAT, and he'll give us an overview on that. So what I'd like to do is just turn the time over to our panelists, and Jonny's going to give us an overview of how technology has impacted this space. Kate's going to talk about a project called FireSAT that's enabling us to understand, detect, manage, and fight fires in really revolutionary ways and the impact that's going to have. And then Steve will give us some insight on how we're going to impact the climate by projects like FireSAT. So Jonny?
Yeah, thanks, Tom. So I guess I was thinking a little bit about how to frame where we are in space. And I thought a good way to do it that I often talk to new employees about at Muon is I like to kind of think about space in three waves, where wave one, going back to the Apollo era, was kind of the big iron mainframe era of space. These were massive billion-dollar, multi-billion-dollar projects that were largely government-driven. And when you look back, and I think some of the previous discussion really highlights this, there was really amazing capabilities deployed during this period, including things like GPS. There's hundreds of billions of dollars of infrastructure now in space that was built in this kind of big iron era. And in a lot of our daily lives, we take for granted the impact that's had on it, whether it is things like GPS for localization, whether it's the way we pull up our app and look at the weather forecast every day, which is highly dependent on satellite information. There's a whole bunch of places where this kind of 50-year buildup of infrastructure in space really touches our lives. And so a lot happened then, but in the early 2000s, people started looking around a little bit and saying, it would be nice if you could do more different things with this, if it was more accessible to things that were not just large government actors. This is when SpaceX started trying to revolutionize launch. In the kind of early 2000s, we started Skybox with an idea of saying, well, can you build much smaller things, much lower cost, leverage commercial technology in ways that haven't been done in space before, and really change kind of the accessibility, the types of missions you can do, et cetera. And I like to think about this as kind of the homebrew PC era, right? So the early days, the Altair, for those of you that were in that world, where there's now a bunch of kind of nerds, frankly, tinkering with kit computers in space and seeing what can be done in a totally different way. And I think, at Skybox, we learned a lot of things. One of the things is that you really can do a lot of these types of missions differently with, again, very heavily commercially derived technologies, et cetera. But in that period, it was still really hard. And the story I like to tell, and Tom will remember this vividly as well, in 2012, when we were trying to launch the first SkySat, SpaceX was frankly a joke. We didn't even really take SpaceX seriously as a launch partner, which is kind of hilarious in hindsight. And so instead, we were flying to the southeastern border of Russia and Kazakhstan to launch our satellites off ICBMs on a missile base in Russia. And that's
out of a silo.
Out of a silo in Russia. And that's what it took at that time for a small commercial player to try and get something into space. Obviously now, today, at Muon, we buy Falcon 9 launches almost like a Southwest Airlines ticket. We can get on quarterly. There's a backlog of standing capacity. And so it's an entirely different dynamic in terms of how you think about not only what the access to space is, but also what can be done there. So that kind of wave two early tinkers in space, I think, taught us a lot about what the possibility was, but there were still a lot of constraints. And I think we're now moving into this, what I like to kind of think is the third wave of space, where it's really about scaling up the learnings from that era in a much, much larger way, in kind of an enterprise or a cloud-like, if you want to keep the analogy with computing, way where a lot of these capabilities that historically were only available to governments, or then for a while were only kind of being tinkered with on the edges around university programs and kind of nerds, frankly, are now going to be available to every company in the Fortune 500, for instance. And I think this is going to be, I think it already is showing itself to be entirely transformative in terms of how we think about what's possible to do in space, the timelines that you can do it on, capabilities. And I think more and more it's going to get woven into just sort of the core economy and everything that happens on Earth. So that's what I think we're kind of right in the middle of. It's a very exciting time right now.
Give us, Jonny, some insight into how sensor development has changed and how it's made it so much more accessible to a whole different set of users.
Yeah, so I mean, I think as is the case with many technology trends in the last 20 years, the way that you collect data about the world has been dramatically transformed due to things like semiconductor technology and other things. So to give an example, Kate is going to talk a little bit about FireSAT in a minute, and we've been working on FireSAT for the last couple of years, and one of the truly enabling technologies that is making FireSAT possible is the commercial ubiquitous availability of infrared image detectors, which really historically were these kind of exquisite things that, again, only government, usually defense missions could buy. They might cost millions of dollars a piece. And due to a number of kind of really innovative technology things that have happened on the semiconductor side and on the cooler side, we can now not only buy these detectors much more inexpensively, but also in numbers. And the key thing for FireSat is really being able to deploy large numbers of satellites so we can get to that very, very, very frequent cadence of revisit and find fires early when they're small, detect them when they're small and kind of early in their life cycle. And all of that is kind of unlocked by these type of sensor technologies that have really advanced just in the last 10 years and made this possible.
So from billions of dollars to hundreds of millions and hopefully tens of millions is the plan.
Or millions.
Or millions, there we go. And I think that's set up well for Kate. So Kate, give us an overview on FireSat and the impact that's going to have on the world.
Why, thank you, Tom, for asking. So welcome, everyone. Thank you for listening to this today. I'm going to speak to you a bit about what you probably know about wildfire and the intersection of space and what you might not know at all about that opportunity. So yes, this is my 48th year in the wildfire industry.
Started when you were 10.
Yeah, thank you. And I was listening to Robert and Trimble and his system optimization and how they've approached transportation and construction as an industry ripe for system optimization. And I want to say that the wildfire space and the firefighting space globally is in the midst of its own transition. It's moving from analog to digital capability. It is moving slowly and sometimes resists that because firefighters on a global basis, and especially the ones here in the United States, really like doing it the way we've been doing it for several hundreds of years. We still do the same process, the same system as we were doing when it was invented in London over 600 years ago as an industry. That is changing. And it's changing rather rapidly. And FireSAT, one of the projects that is central to that, is just emerging. So a quick rundown of the FireSAT project, of which Steve was there at the early design phase, began as a concept of problem statement. We have lots of fire. Firefighters don't know where they are relative to fire. There is no mechanism out there yet to be able to see exactly where a fire is located to a fine granular detail and see myself as a firefighter on that fire line. That's one problem statement, and one of the early ones that firefighters will tell you is their pain point. When Environmental Defense Fund and the Gordon and Betty Moore Foundation that I represent here today started tackling those kinds of problem statements, it was how can we create a capability to detect wildfires early and suppress them when they are small. That has a carbon impact, that has a climate impact, that has a public safety impact. Great mission. That was the original genesis of the FireSAT project. It is a 52 satellite low Earth orbit system. Prototype was launched, built by Muon Space, in partner with a nonprofit business delivery model. That nonprofit has been formed. It's called Earth Fire Alliance. The CEO is sitting in the back. Wave your hand, Brian, please. Chat with him. Brian has been a partner of mine for 20 years plus. We co-founded a software company 15 years ago, bootstrapped that to success, did a partial exit, and now we've moved on to this charitable side of the world through the Gordon and Betty Moore Foundation, also represented here by Jennifer Biggs. Jenny, wave your hand, chat with her. We are both talking to you, I'm talking to you both about the opportunity for investment capabilities in things like Muon and FireSAT, but also FireSAT itself at this time is a philanthropically funded launch. Our next 3 satellites, Proto went up in March. I think we're just beginning the data stream analysis for that. Next 3 operational satellites will go up next March, again, on the Falcon bus and scheduled for full data delivery. We have gathered 6 lead fire agencies from around the world to beta test our prototype data and to make entry into the international wildfire space. So we're very carefully constructing an ecosystem of users as well as best-in-class hardware, sensor capability. But now I'm going to transition to what you might not know about the wildfire space. It seems obvious to us that we need to put fires out. They're threatening. We watched LA, we watched Lahaina in Hawaii, we see Africa, we see European, Mediterranean European countries. We see a threat of wildfire. That is the human reaction in today's industrialized age to wildfire. But it is a conditioned reflex. I'm just going to give you a statement here. For the United States, we burn on average 8 million acres of vegetated forest, grassland, savanna, hardwood acres per year. 8 million. That is far too little fire. We actually need to be burning in excess of 20 million acres per year if you were looking through an ecological lens about a healthy functioning ecosystem, sustainable watersheds, biodiversity, the ability for our ecosystems to maintain themselves in a highly functioning way is dependent in many, many places, not all, but many, around the planned or the sequential reoccurrence of wildfire. But yet we have suppressed that effectively, and this system will give will give us better capability to suppress it. We're going to get more efficient at suppressing it in the decades ahead through the systems that we're creating like FireSAT. But that is going to take us into a further fire deficit than what we have today. We do not have enough wildfire in the United States, and specifically in the West, where watersheds are the key flywheel driver of much of the economy of the West. And we are headed for a very difficult problem as climate warming increases and we get better at fire suppression. Yes, we'll protect communities, but we are driving our watersheds into a difficult position for where recovery for water yield, forest recovery is going to diminish. So here's the opportunity with FireSAT. It will not only give us detection and monitoring, where am I as a firefighter, where is the fire, how do I get a system out there to suppress it quickly when it's smaller sized, but because of how the sensors are constructed and calibrated, we will also be able to see at a less than 1 acre granularity, we will be able to see how hot that fire is burning. And really, the issue that we need to address with wildfire is counterintuitive. It's not how much there is, it's how hot it is. How hot it is what makes the difference between a good fire, ecosystem-wise, and a bad fire, damage-wise. So we need to rebuild the suppression system and the fire management system, not to be binary, not to be analog, but we need to use our digital tools coming up. And when we talk about future thinking, I'll bring up the AI and the autonomous capabilities and how we envision merging those. But we really need to shift the whole fire management system to a moment of choice. When the fire begins, do I, as a fire response person or a fire manager, do I have a choice about what to do with that fire? Because I understand its details, I know how to manage it better, and I have systems in place that allow me to turn that dial of intensity like you do on your gas stove or your barbecue. I can turn that intensity up and I can turn it down based on what that particular ecosystem and the particular conditions of today allow me to do safely. We'll talk about that in our questions. Thank you.
Thank you. Steve, tell us a little bit about MethaneSAT.
Yeah, so to segue, that Kate talked about is we need to think about these impacts, and she mentioned it. So we have all these fires. You can think back a couple of years, if you were in New York, certainly, to the Canadian fires, and the amount of material that reached New York, along with the massive quantity of greenhouse gases that were put up. And you will have heard numerous estimates of what that was. Those were all estimates, calculations, not based on data. And actually, the overwhelming majority, more than 90%, probably more than 95% of all of our greenhouse gas data is estimated. It's calculated, not measured. So the vision behind MethaneSAT was to try and ensure that we could have greater, more effective action, just in the way that Kate described FireSAT system. We wanted to drive a vision of being much more effective using the latest technologies, and we thought that was possible. And we needed to answer 3 basic questions. And the reason we were looking at methane in particular is it's very powerful as a greenhouse gas, and it's responsible for just about 30% of the warming we experience. But unlike carbon dioxide, if we reduce those emissions because it's short-lived, we get climate benefit very quickly. So it's kind of like the down payment. We get to do that and slow down warming very quickly if we can reduce it while we address carbon dioxide emissions. But we need to answer 3 questions. Where were the emissions? How much were the emissions? And how are they changing over time? You'd think we have that data. We do greenhouse gas measurements from space currently for science, not for action. So we envisioned a mission that would try and address that gap. And to do that, we needed a couple of things. We needed much greater precision in our measurements with respect to detection of those emissions from the ground, concentrations, what you measure. We also needed it spatially resolved, but we needed it at the regional scale. So we actually used empirical data that we'd been collecting with hundreds of scientists here in the United States to quantify the pattern of emissions, to reverse engineer and say what would meet the needs to reproduce what we could do on the ground from space, which meant we needed a very high precision spectrometer, 2 parts per billion. You can ask Tom about that, because when he got involved, it was a very audacious. Everybody said we couldn't do it. We actually have produced a satellite with sub-part, 2 parts per billion detection threshold, meaning we can see differences in concentration at the surface of the Earth with differences less than 2 parts per billion. We also needed, as I said, that spatial scale. But we needed a third thing. So that produces a wonderful map of concentration, but it doesn't tell us, it doesn't answer those 3 questions. That's not policy relevant. It's great science data, and I'm a scientist, I was a professor for a long time. It's great data to play with, but it doesn't kind of do the on-the-ground action you heard about fire that we need to do for greenhouse gases. Where do we look? What action do we take? So we needed to build the software to convert all of that into the actual flux map. How much is being emitted where? Doing something called an inversion. No satellite before we launched MethaneSAT had the software to do that in an automated way so that all the data we're bringing down and putting out was flux data products. So that was the vision. And this has been a challenge. We're an NGO. We brought in commercial space. Tom helped us greatly. Jonny helped us, and a whole group of other folks that allowed us to put this mission together and bring that data down, and doing it at a fixed price contract, which, because we as an organization, I couldn't go back to funders, there wasn't any more money to be gotten. That has allowed us to start to produce these data in a way that we've never had before, and allows us for the very first time to provide quantitative greenhouse gas measurements over time for an entire sector, the oil and gas industry, production of oil and gas, on a global basis. Think about that. How much we need to do to address climate change. It's real, despite what we're hearing. It's real, and it's impacting all of us. If you live in New York, you've certainly experienced it in many myriad ways, in almost every place we live. Everywhere in the United States has experienced it. But we did not have that quantitative data to make the comparisons. We are building that data set now. We launched just over a year ago. We are producing data. I have told, and many people recently, if I really understood how hard what I just described was, I would have never agreed to do it. But it's been an incredible journey, a collective journey. I believe it's a model for doing this in many other contexts. We are looking at agriculture as a second priority, and we are going to do some others. We are limited because we built this, and Ball Aerospace, now BAE, is the one who built this incredible spectrometer. So our downlink capacity, because it's very data intensive, is our constraining factor. But I do believe we are, with respect to greenhouse gases, we're undergoing a data revolution that'll allow us to have radical transparency that'll turn the whole climate issue on its head and provide an ability to much more effectively understand the problem and the solutions. Right now, we've got very fuzzy glasses on. We're trying to put really crisp glasses on.
Thank you, Steve. The impact of the projects that we're hearing about here today really are global in scale and are going to have a tremendous impact on future generations. It's been wonderful to watch them happen. Jonny, give us some idea of what's next. Where's industry going, and what capabilities are going to be out there? And I would like to offer that same question to Kate and Steve. Like, what's next, and what do you see the impact of your project having in the next 5 to 10 years?
Yeah, so I think, kind of given the nature of this panel, I'll kind of answer it in 2 ways. So I think from a pure kind of industry perspective, what I see coming is that we're kind of moving into this place where space becomes just part of the general economy, and many, many more entities are going to be doing things in space than we ever thought was possible before. And I think about things like a world where there's tens or hundreds of constellations of satellites in low Earth orbit, doing a very wide, a hugely diverse set of things that maybe we haven't even imagined today, and certainly didn't think was ever viable from a cost or timeline perspective to do. And they're all meshed together in a network that looks like the internet, and we much more see that infrastructure in space as just sort of a transparent extension of the infrastructure we have here on Earth, the sensors we have on Earth, the compute technology, all of those things. It's going to be much more transparent between kind of terrestrial infrastructure and space infrastructure. And I think we're very rapidly approaching that time. From a what does that actually do from an impact perspective, I think that allows you to start thinking about, again, doing all kinds of new missions, deploying new capabilities that historically you wouldn't have really considered as being viable. I think things like MethaneSAT are a really good example. I think things like FireSAT are a really good example. I think back to a time, not that long ago when the idea of having networks of cameras on Earth all connected to the internet, constantly streaming information into the cloud was a fantasy because of the capabilities of the network, of the capabilities of sensors, how much cameras costed. And you think about that same analogy extending to space, where now we have the ability to deploy mass numbers of diverse sensors that are kind of closing the loop on everything we do on Earth. And I think that's a really invigorating future vision, and I think we're actually very rapidly approaching it, so it's very exciting.
And where do you see cost and performance going in the future? Because I know when you think about nonprofit organizations now sponsoring massive, scientifically based satellite projects, I mean, 10 years ago that would be unheard of, right?
Yeah.
Where are we headed?
So, I mean, I think we're already kind of, an order of magnitude down, or even maybe a little bit more than that. If you think back 20 years ago, what it cost to deploy these capabilities, because of all the trends we're seeing in terms of things like on the space side, Starship, which is going to dramatically lower the cost of putting a kilo in orbit further, as well as all the other kind of technology trends that are tailwinds for us, things like even things like AI and being able to deploy AI into the satellites themselves. I think we expect another order of magnitude, and I think that will inherently then create an order of magnitude or more increase in sort of how space is utilized and the impact it can have.
Great, thank you. Kate, where's FireSAT headed?
Up. FireSAT, like I mentioned, the business model for FireSAT is a nonprofit delivery model at low cost, free or low cost to fire responders on a global basis. Behind it, though, are other business models that are worth talking about because there is a business case to be made for the FireSAT mission. And that is the spinning off of the capabilities of that information that extends to industries and communities that exist beyond the firefighting space. So that's why we're here. It is not just a charitable do-good project, which it is, and you're happy to invest as philanthropers in that project as well. But there is a business case about wildfire and its relationship to climate and how it's going to be central to climate change occurrences, as well as the industries that kind of support that, i.e. the insurance industry or the community development industry, pieces of that. The water industry is going to be intimately involved. So so that's why I'm trying to make the case for what the investment potential in the future is for FireSAT as a course of business. In addition, let's talk about what the technology is going to do. So the FireSAT at the 52 full orbit satellites scheduled to be launched by 2028. That's part of the funding process that we're going through. First 3 I mentioned next year. It will deliver to us a couple of different data streams at a global level. One is it will be a detector of, like a bang detector, a detector of fire occurrence at a 1/4 acre scale and noticing. So that is its design. Watch the X Prize competition, which is a global competition right now for companies to both detect and suppress. Just tune into the X Prize Wildfire Challenge. But the FireSAT will deliver a 1/4 acre bang detection of fire occurrence as a start on a global basis, and then it will track the perimeter of fire growth on a global basis simultaneously. So we will see the volume of fire. Firefighters will be using that edge technology to develop their firefighting strategies. And then, as I mentioned before, it will also, on roughly a 1 acre granularity scale, give us a heat intensity, so differentiated pixels at roughly 1 acre size can be calibrated to different heat intensities. And that is where we'll start to rebuild a new firefighting system, a fire management system that relies heavily on the ability of autonomous aircraft to go into the interiors of fires and calibrate those and prevent the high heat losses that are occurring at the interiors of large wildfire scale fires. I want to call this out. So there's two very divergent problem sets. One is Los Angeles, Hawaii. How do you get information fast to the ground to make the critical decisions at those very short and compressed timeframes? That is a suppress fire at all costs problem set. And then there is fire large landscape, actually doing some good out there. Does it matter if it's 100,000 acres or 1 million acres in size? It doesn't. If it's 1 million acres in size, that might actually be a beneficial impact if it can be tuned at the right intensity level. And this is a complicated problem. It's going to take us some decades to get there. And there is a lot of artificial intelligence work that's going to need to be done. We have to build the multimodal models. First, we're going to have to put the right data in those multimodal models. We have to collect that data at the ground scale and at the aerial scale, and with multiple sensor arrays. And then we have to figure out the right training processes that mimic, from a firefighting standpoint, the legacy decision flows that firefighters use, because we can't disrupt the whole system while we're doing that. So a lot of artificial intelligence. If you want to talk to me about autonomous capabilities, very involved in figuring out how to design that system. And I'll just leave with painting one picture for you. I'm imagining it's 2050. I'm imagining that we've absorbed all the FireSAT data, we've built the models, our AI is working, and now our fire response system in Colorado looks something like a very large heavy lift drone system that is holding roughly 50,000 gallons of water aloft. And I'm working 100 different heavy lift drones and helicopters delivering that water to the interior fires. And I have very few humans in the loop at that point in time. And we're doing that at scale. And then we're going to start to get to fire at an appropriate level in our ecosystem capability.
Great, thank you. Steve?
Well, I think that what I see happening is that rather than having one satellite, MethaneSAT, that we take the existing satellites that are thinking about greenhouse gases, and they all start to look more like MethaneSAT. So we've got, the Japanese are launching an incredible satellite, GoSat GW, hopefully later this year. But it's still framed in terms of science. They're beginning to think about this now in a more of a policy context. How do we provide the data that I described to answer the questions I talked about? I'm starting to see that vision starting to develop. And I think it's very exciting, and that's what we have to do. We have to turn this into, just as we heard earlier about the whole story of Trimble, right? What was a science exercise and was rare, was inexpensive. All of the greenhouse gas measuring sensing is right now is very expensive. It's the kind of thing you do. The US is thinking about the next mission 2030, even if it goes up. This just doesn't work. And I don't think that's what's going to happen. I think we're going to get this data revolution. But in the shorter term, we actually have the capacity to look at CO2 as well. So we'll be bringing out a CO2 product to go along with our methane product to begin to look at how well can these types of high precision data actually change our understanding of the problem that we face with climate change, and in turn, what are the solution sets? I personally believe, just as we've seen so many times, and we heard this great example prior to our panel, of we're at a tipping point now, and we really can see a different way of collecting data and using that data to drive change. I was an academic for 25 years. I left academia because I wanted to have more impact. And many of you may have had academic careers, but you went to the commercial side. I decided to go to the impact side and join a large NGO that could help drive the change. I see that kind of revolution coming, and I'm really excited about the potential impact to really accelerate mitigation of greenhouse gases, which we all need. Because if you don't understand, I'm happy to take you to various places around the world and show you some of the impacts. They're very real, and that's actually why I left academia, because I saw in my own plots, I'm a forest ecologist working on disturbance ecology, I saw in my own plots what I thought would happen long after I'm gone was happening. Things are changing on the ground in very quick ways and accelerating ways, and the need is ever urgent.
Steve, putting you a little bit on the spot.
Sure.
Didn't prep you with this question, but you've got a lot of very creative, innovative, brilliant people in this audience that have ideas, pursuing different opportunities. What kind of resources do you see that MethaneSAT could utilize to help get the word out, to help distribute the data more fully? And I could ask that same question of Kate. What need do you have from the entrepreneurial community to help build the capability of FireSAT and of MethaneSAT and others like it?
Well, we currently are really trying to explore that commercialization model and the challenge of creating something new, because we need to have openness, right? So we promised everyone can have access to the data. At the same time, there are lots of additional things you can do with the data. How do we commercialize that so we can create a stable business model? And we're in the middle of those conversations. I won't mention any specific names, but we're all ears, because we have a whole new product no one's ever seen. So we've been just going out there talking to people about it, trying to understand how can we do this sort of transparency and add value to what we're able to produce in our Flux data product, our level 4 data product that we produce. I think there's a real opportunity there to think about this ecosystem in a fundamentally new way and see the leverage and sort of get out of the mindset that a calculated number is going to be a good reflection of reality. It could be in theory once we get past our current roadblock, which is we have so little empirical data that we basically don't estimate it well. And we've got to get past that and start combining data in new ways to really create those new insights.
So an incredible new data source with data that's never existed before, data that we know it's important, data that's being generated from assets that were built through philanthropic sources.
100%.
So it's data that doesn't have a lot of cost attached to it, but yet to make that sustainable, we do need to find other applications and ways that could help generate some revenue to make that more sustainable and to perhaps allow that to grow. And I think, not too dissimilar to GPS, right? Where the system was put out there, okay, there's this great data, now what can we do with it? Just a quick little story. A friend of mine was a captain in the U.S. Air Force on the GPS program, and he said he spent a number of years trying to fight to keep the funding for the GPS program because nobody in Congress could imagine the need for a GPS. We have maps, we have compasses, why would we ever need a location signal from space? And I think as we sort of postulate and think about some of these new systems that we're developing, new data, we need to find creative entrepreneurs that are going to look for ways to apply this and to generate the value and the impact that data brings. What about from your perspective?
Man, your
Kate?
story gives me traumatic stress response. when Brian and I started our company in 2010, we were giving a presentation to fire chiefs in California. He's laughing already. We were giving a presentation to fire chiefs in California about what we were building, which was a simple today, but common operating platform, get all the data aggregated, serve it up to firefighters at the time of firefighting, et cetera. That was our vision. And the fire chief of Los Angeles at the time, 15 years ago, stared at us and said, why would we need that? And here we are today, wishing, front page news, wishing they had that. So, which they do now because we just sold it to them. So what we need in the FireSAT ecosystem space right now are companies that are really good at data aggregation. We have a lot, in order to do what I described before, the autonomous, I see we're at a minute, so shut me down if you need to, Tom. But
Never, Kate.
Thank you. But I described FireStart, FireSAT detection, data transmittal, build a system of fewest humans in the loop possible based on autonomous. That's how we scale this across the United States globally. In order to do that, we have to have AI be able to do 4 simultaneous tasks at a massive data scale. And that is, we need to understand, for that little plot of ground, we need to understand what the historical fire occurrence was in that particular area and its related ecosystem impacts. We need to understand at that moment what the fire is doing. We need to have all sorts of terrain and weather and action information about what's burning at that moment, what impacts it's having at that moment. And then we have to have AI be able to calculate for that particular plot of ground, that might be tens of thousands of pixels at a time. We have to then be able to compare that to what is the optimal condition that ecosystem needs to be able to survive this level of fire at this moment, notwithstanding the smoke and carbon and other impacts it's going to have. And then we need to have a fourth analysis occurring, which is, I know what optimal should look like, but I'm in the reality of climate change today, so I need to be able to predict forward what optimal is best available optimal against the fire at that particular piece of ground. So we're going to have to run a set of data and analyses against every piece of ground, at least through 4 different AI analyses, and be able to serve that back out to the autonomous capability so that they can tune cooling mechanisms to be able to bring that fire down. Or we're going to figure out some other ways besides having to use water, and I hope our other friends out there in the material science worlds might bring us some answers on that. So there's systems, there's data aggregations, there's, like I said, a lot of questions that need to be asked at scale, very large scale.
Well, thank you, Kate. I want to thank our panelists for joining us. And if any of you got some clever ideas on how to help Steve Hamburg think through giving the world greater access to the MethaneSAT data, different ways of thinking through building application layers on top of that foundational data, I'd be more than happy to put you in touch with him. Steve is executive director. Not only is he the chief scientist at EDF, but he's also executive director of the MethaneSAT project and has got an amazing team and is looking for ways to leverage this tremendous investment they've made. And I want to thank our panelists for their great insight and for all that you're doing. So a round of applause for them. Thank you.